Assalamu alaikum all of you. Now today is our first virtual lecture. So I repeat that thing that I discussed in the face-to-face class. Today I explain it through PowerPoint slides. You can see it and understand it very clearly. So can you see the PowerPoint slides? Abdul Rahman, can you see the PowerPoint slides? System of linear equations. Yeah, okay, Talal. Today we discuss the system of linear equations in linear algebra. So these are our topics: system of linear equations. First of all, we discussed an introduction, and then find unique solution, and undetermined and overdetermined systems. Then after I discussed the matrices, multiplication of the matrix, the inverse of the square matrix. These things today I discuss. So very first of all, now I move over here. So our first point is system of linear equations and introduction. As I discussed in my face-to-face class, Abu Bakr Hussein, these are my PowerPoint slides. I built it from myself. So if you want these slides, then just come at my room before 1 hour of your class, and I will give you. So otherwise, these slides are from the books. You can just check your books. These are available on your books. Just read your books. Everything is on the book. But if still you want these slides, then okay, no problem. Just come 1 hour before your class. So now I'm going to start my first lecture. This is a system of linear equations and introduction. So as I discussed in my first class, we have two equations, two line equation. One equation is 2x minus y is equal to 1, and with the help of this I draw the straight line. In my face-to-face class, as I told how we can draw the line from this equation. So in my class I tell you, this is the wait a minute. In my class I tell you first of all I draw the checkbox over here, and after that I write over there x and y, the value of x and the value of y over there, and first I put the 0 over here and put the value of x 0 over here, and then we find the value of y. Then if we put the value of over here 0 over here, then we get the value of y is equal to if we put x is equal to 0, then value of y is equal to -1. Similarly -1, and similarly after that I put the value of y is equal to 0. Then after I get some value of x. So this is the method. From this method I draw this straight line. 2x minus y is equal to 3. Then I have second straight line. This is another straight line. So with the help of same method as I discussed I draw the checkbox over here and put the values x and y. And after that x and y, after that first of all I put x is equal to 0, then I got some value of y. Then after I put y is equal to 0, then I got some value of x. So with the help of these two values x and y, I draw this line. This is a line 3x plus 2y is equal to 12. I will discuss these things in the face-to-face class very clearly. So this is my two lines equation. This is a graphical method. From this graphical method I draw the lines, and this is the solution, where the solution is where these two lines are cut. This is called the solution. 2 and 3 are the solution. So this is one method. to solve the system of linear equation. But this is an old method. This is an very and now we discuss some another method to solve the system of linear equation. Now next, um, system of equations. Recall that the system of two linear equations in two variables may be written in the general form: ax is equal to ax plus by is equal to h, and cx plus dy is equal to k, where a, b, c, d, h, and k uh, are real numbers, and neither a, b, c, and nor b is 0. Recall that the graph of each equation in the system is a straight line in the plane, so that geometrically the solution of the system points intersection of the two straight line L1, L2 represented by the first and the second equation of the system. So given two straight line L1, L2, one and only one of the following may occur. If as I discussed in the face-to-face class, if we have two lines, one line L1 and another line L2, then there are three possibilities of this. So first possibility is this: there are 3 points. First point is this: if L1 and L2 intersect exactly at one point. This is the first case. If we have two lines, then there are three possibilities. The number one possibility is they cut exactly one point. This is the point they cut. So this is the first possibility. And if it is happens, then we called it is a unique solution. We called it is a unique solution, x and y, x1, y1. So this is first possibility of the things. So remember it, if we have if these two lines cut exactly one point, then we call it is a unique solution at x and y. Now the second point. Second point is if given two straight line L1 and L2, one and only one of the following may occur. The second point is L1 and L2 are coincident. The meaning of coincident is one and there are two lines. If we have one line L1 and if this is L1, and if we have another line L2 on the same on its upper, this is L2. L1 and L2 are the same, then it is called a coincident. So here, as you see in the graph, L1 and L2 are coincident or the same line. Then we say that there are infinitely many solutions. So this is the second point. If we have two lines and they are coincident, then we say it is a infinitely many solution. Now the last point, the third point, if we have two lines, the third point is if we have two lines and the two lines are parallel. This is the third point. If two lines are parallel, then this is called the no solution. L1, I will tell you, wait a minute. If we have two lines L1 and L2, then there is no cutting point between these two lines. Then we say it is a no solution. There is no any solution. So the solution means we have a solution. First of all, you understand the meaning of solution. What is a solution? Where the line cuts each other is called the solution. So this is the solution. This point is the solution. So if I say there are three lines cut over there are three lines cut at the same point, then we say this is the solution. So if a line, for example, if a line and another line cut over here and here, it is a graph of the sign, then the solution is this is a solution, this is a solution, this is a solution. There are so many solutions over here. So similarly, I repeat it. There are 3 points earlier. So in first point, I say that if the two lines cut at one point, then we say that it is a unique solution. It is a unique solution. And in the second point, I say that if the two lines coincident coincident means one and upper. If the two lines are the same, if one line and another line on the same thing, these are if two lines are the same, it means coincident. So it has infinitely many solutions because of the two lines are the same. Of course, there are infinitely 1, 2, 3. There are one solution, two solution, three solution, four solution, five solution. There are so many infinitely many solutions. That is why I say it infinitely many solutions. So, and the third point, I say if two lines are parallel, any meaning is that there are no cutting point between these two lines, then we say there is no solution. So the three things are clear. So Fahad, are you clear these three things? Now I move further. Okay. Uh, so there are some examples of the three things. A system of equations with exactly one solution. So a numerical example they are given. They are considered the system of equation. As I given in the face-to-face class, there are some examples over here. I also give some other examples. So there are two equations, 1 and 2. Solving these equations, I will either I multiply with this with the 2, or multiply by with the 2, multiply equation 1, and with equation 2 I multiply something else. Then we cancel it out, and something at, then we get the value of x and y. There is one thing. And substituting clear then the blackboard. Yes, Muhammad. Yes, Muhammad, as I told you, you can get the slides from me before 1 year, before 1 hour of your class. You can come at my room. I will give you these slides. So after that, substituting the expression of y and the second equation and yields, there are so many methods I can solve it. So either I cut here or I cut here, I can get the value of x and y. So this is the value of I can get the value of x and y. Now next. A system of equation with exactly one solution. I finally substitute the value of x into the expression for y and obtain the early gives. Y is equal to this, and we get the value of x and y here. Therefore, the unique solution of the system of equation is given by x is equal to 2 and y is equal to 3. These are the unique solution. So there are so many ways I can find the value of x and y. So this, so as I take one example in the face-to-face class, this is another example. So everyone have to know how we can solve these equations. So so a system of equation with exactly one solution. Geometrically, it says how we can represent the system of equation. As I told you, we first of all we draw the first line, and secondly we draw another line. Then over there they cut. That is the solution. So geometrically, it shows you there are the two lines representing by the two equations that make the system of intersection at the 2 points. So similarly, if someone says geometrically you show that it is a true. For example, these we obtain the value, these two values, x is equal to 2 and y is equal to 3 are the solutions of this equation. 2x minus y and 3x minus plus 2y is equal to 12. Then if someone says just tell me geometrically how we can see these are the solutions. So geometrically you have to show that first of all you have to draw the checkbox as I told you, and over there you find the value over for right x and y, here x and below y, and put x is equal to 0, then you get the value of y something, and then again you put y is equal to 0, then you get x is equal to something. So with the help of this you draw a straight line like this. So similarly 2x minus y is equal to 1. Similarly another time you also draw the straight line like this. So these two lines are cut exactly the same points that we find in previous. The 2 points are cut at 2 and 3. Here is 2, here the distance is 2, and here the distance is 3. So this is the solution. And if we see previous slide, I found that there are the two solutions, x is equal to 2 and y is equal to 3. So similarly, I can get the values by graphically. Now, a system of equations with inequality infinitely many solutions. So there are some other solutions. If some equations have infinitely many solutions, means they are not cutting each other. So it says, let us take some example, 2x minus y, and this is an example. And on the same way, I I draw multiply with this and cut it and get the value of x, and cut it and get the value of y. So we observe the solving first and first equation for y in terms of x. We obtain this and substitute this. This is another. So we obtain the 0 is equal to the 0. So this is the value we obtain, which is true statement. 0 is equal to 0. So we don't get anything. So this, if both sides are equal, then we say this result follow from the fact that the second equation is equivalent to the first equation. So this is an example of a system of equation of infinitely many solutions. If this case happens, then we say that there is an infinitely many solution. Thus, any order pair of numbers x, y satisfy this equation. This constitute the solution of the system. The assignment of the value t or to x, where t is any real number, we find y is equal to 2t minus 1, and so order pair t 2t minus 1 is also a solution. There are so many other ways to find any solution. So there are infinitely many solutions. This is the graph of the infinitely many solution, because of the two lines are coincident. Because of one and another, there are two lines, and these two lines are same. That's why this is a solution. So another example, the third one example, a system of equation that has no solution. If for example, again I consider it, there are two equations, equation number 1 and equation number 2. There are two equations, and if I want to solve these two equations, so how we can solve? Multiply this equation by 3. Multiply this equation by 3, and then subtract it, and then cancel it. Then you get the value of x and y. So when you get the value of x and when you get the value of y, so you observe that there is this is the cutting, this is the cutting. Then you observe that we obtained the value 0 is equal to 9. So this is a not type, which is clearly impossible. It is not true. So as I discussed in our face-to-face class, I take some another example. Over there I observe that left hand side is equal to 0, and right hand side I obtained some another value. So I say this, there is no solution to the system of equation. So clearly there are 3 points I discuss over here. First of all, I discuss a unique solution. Second, I discuss there are infinitely many solutions, and the third point I discuss there is a no solution. Now next. A system of equation that has no solution, by graphically it shows to interpret the situation of geometrically. It shows cast both equation, draw the graph of this equation. First of all, I draw the graph of the equation. This equation y is equal to 2x minus y. Y is equal to 2x minus y, 2x minus 1. This is a line of that graph. Then again I draw y is equal to 2x minus 4. So when I draw this graph in the graph, So I observe that there is no cutting between these two lines. Yani either this type of cutting, we don't observe this type of cutting. So there are the separate lines. So I say that there is a no solution. Graphically, I observe that there is no solution. Now next thing, system of linear equations, unique solution. How we can say there are unique solution. So if we have three sets of equations, so there is a Gauss-Jordan method. How we can operate Gauss-Jordan method? On that day, on the day of face-to-face class, I told you the methodology how it works. Gauss-Jordan method. If we have a system of linear equations, then first of all I write a uh, what type of matrix? I just forgot. Augmented matrix. First of all, I write a augmented matrix. This is the augmented matrix. This is, if we have this type of equation, I write 3 over here. I write 3 over here, and 2 minus 2 over here, and 1 is here. Here is 1. I write 1 is over here, and after that, after I draw a line, this is a line, this, and after that I draw these things over here. So this is called the augmented matrix. This matrix is called the augmented matrix. So now I will tell you how to solve this type of equations and what is the criteria. So here are some points. The Gauss-Jordan elimination method is a technique for solving a system of linear equations for any size. The operations of the Gauss-Jordan method are interchange any two equations, replace an equation by a non-zero constant multiple of itself, and replace an equation by the sum of that equation and a constant multiple of any other equation. So these are the some written rules that we use in Gauss elimination method. So in my language, I told you in the class that if we have a equation, if we have a matrix, then our first aim is to write at first element should be 1, then rest of the element in below it is 0, and our next element is 1 over here, and the next element is 0, and the third element something whatever, and the first and the third element is 1. So this is our aim, to write a lower triangular matrix. Here is 0, here is 0, here is 0, here is 0. There are 3 zeros must be, and the diagonal elements are 1. So the conclusion is this: we have to convert the matrix into this form by multiplying anything, by adding something, by interchanging row. There are 3 rules. With the help of these 3 rules, I form the matrix like this. These are the 3 rules. With the help of the 3 rules. So now I will take some examples. With the help of example, you can understand. So solve the following system of equations. These are the equations are given. So these are equations are given. So first of all, so we have to solve it. Find the value of x, y, z. So first we transform this system into an equivalent system in which the coefficient of x in the first equation is 1. So there in this slide use this in this method, but in my face-to-face class I use first write I over here 1 write in the matrix form. So let us see how it solve. So solve the following. Next we eliminate the variable x from the equation except the first. So replace the sum of the, in this slide it shows in the system in the linear equation, but my in face-to-face class I write in this type of equation in the matrix form, then I try to solve. Because of it is there is no need to write x and y values, but in this slide I write some values, but there is no need to write. I just write like this 1 3 and -1. There is no need to write like this. uh, and just operate and just write the operations and try to solve this type of equations. So finally I find it, we operate it, and like after applying the operations I found it by eliminating the variable x from the equation except the first. So in the next slide, similarly this is the next, and again I found it, replace the sum of first. So again and again I operate it. So I found it, replace the sum of the first equation plus the third equation. There are some operations that we have to apply, and then we transform that the first equation of the equation 1 multiply the second equation. There are this we apply over here. Now eliminate y from the equation except the second term. So there are some operations I apply, and finally what I got, let us see. Finally, yes, one by one it is removing, and finally yes, finally I got this value. Don't confuse it. It is a matrix like this: 1 0 0 0 1 0 and 0 0 1, and augmented matrix, and there is 3 1 and 2. In a class I write like this. So this is the final results that I obtained. This is same as it is the same. Either I can write like this or this. So what is the value I obtained over? The value of x. What is the value of x? Just tell me, Fahad. What is the value of x in this slide? Yes. No, the value of x is not 1. Yes, the value of x is 3. And the value of y is 1. Right, Talal. And the value of z is equal to, yes, right, Talal. And the value of z is equal to 2. So this is the method we can find the value of x, y, z. So in this, first of all we have to write augmented matrix, then we have to operate the row operation, and after we have to apply, and finally we convert the matrix into this form 1 0 0 0 1 0 0 0 1. So we obtain the value of this. Now next. Solving this, take another example. Solve the following system of equation. The solution is x is equal to 3, and directly I get the solution. So after solving this equation, I get the solution: x is equal to 3, y is equal to 1, x is equal to 2. You can solve yourself at your home. So now it says what is the augmented matrix, but I told you earlier, but again it is a definition. Matrix are rectangular arrays of numbers that can add us by eliminating the need to write the variables at each step of reduction. For example, the system, this is the system are given, may be represented by the augmented matrix. So this is the augmented matrix. So first of all I write this coefficient matrix. I write 2 over here, and similarly 3 over here, and -1 over here. So this is -1, and are the same. And similarly I write with the first of all I write the coefficient matrix, then I put the straight line, then I put all these values. So this is called the augmented matrix. Every steps in Gauss-Jordan elimination method can be expressed with matrix rather than the system of equations. Just simplify the whole process. Steps express the system of equations. So steps express the augmented system. This is the now I discuss now here in this slide here we discuss how we can write the system of equations in the matrix form. So these and this are the same. These are the this and this are the same. Both are the same. So every step. So steps expressed now. Here I show every step is both the operations I apply over here as well as over here. Let us see over here. So first aim I have to write 1 over here in the previous slide. As you observe that this is 1 3 minus 1, and in this slide I write 1 3 minus 1, and now I write 0 over here. With the help of row 1 I apply 0 over here. Now our next target is we want 0 over here. So what operation I have to apply over here? So I want R3. So I have to apply the operation R3 plus R1 plus R1. Yes. So if I apply this operation, yes, Fahad, if I apply this operation, then this will become 0. Now on the next slide we will see. Yes, this becomes 0. This is 0. This is 0. Now what is our next aim? What we want to do next? Yes, Abdul Aziz, tell me what is our aim? What I want to do next? Abdul Rahman, Abdul Aziz, tell me what is our aim? What I want to do next in the matrix to find the value of x, y, z? Or anyone tell me what I will do? Find R2 in R3, 3 becomes 0. In R3, 3 become, yes, this is we want R3 become we want this 3 will be 0, but before 3 will be 0 I have to do over here I want 1 over here. I want 1 in this place. Then after I apply the operation, and then after, so I want in place of 2 I want 1. So I apply some operation over here, then I got the value. So to apply 1, so what I have to do? I have to do R2 divided by 2. So I have to divide R2 divided by 2. I got the value 1. Now I apply. Now I want in place of 3 I want 0. So with the help of 2 I apply the operation. So with the help of 2 I apply the operation and observe that. So this is a 0, and this will become 0, this will become 0. And now our next aim, what is our next aim? Our next aim is I want 1 in this place. I want 1 in this place, yes, R3. And after that I can get the value, yes, after applying the operation we will get 1 in this place, and then again I will solve it, and 0 after that, and after that I will get this all the 0. This is the unit matrix, row reduced form of the form. So this is the matrix. Then similarly you can find the value of over here. The value of x is equal to 3, the value of y is equal to 1, and the value of z is equal to 2. So this is the procedure to solve the system of equations. Now next, row reduced form. Each row consists of entirely of zero list below, all rows having non-zero entries. The first non-zero entry in each non-zero row is 1, called leading one. In any two successive non-zero rows, the leading one in the lower row lies to the right of the leading in one of the upper row. If a column contains leading 1, then the other entries in that column are 0. These are the rules of the row operation, how we can apply the row operation. Interchange any two rows, there is no any problem. Replace any row by a non-zero constant multiple of itself. Yes, we know it. And replace any row by the sum of that row and constant multiple of any other row. So these are the rules. These are not hard, but you have to I write it, these are the rules, but we have to know these things. um, but you have to concentrate over here, then after that you can solve it. But we have to in our mind we have to know these things, that we make the matrix like this: 1 0 0 and 0 1 0. So this type of matrix we have to draw, and whatever the operation we apply, and it is up to you. So these are some rules. And a column is a coefficient matrix. Matrix is in unit form if one of the entries in the column is 1 and the other entry is 0. A pivoting element, the pivoting element is that element that is 1 is called the pivoting. For example, if we have a this type of matrix, then this element is called the pivoting element, pivot. Or another time I use 1 over here, then now this time it is called the pivoting element. So this is the definition of the pivoting: the sequence of row operation that transform a given column in an augmented matrix into a unit column. It is called the pivoting. So notations for row operation. So these are the I discussed this operation in the class. Ri denote the ith row of the matrix, and with the help of I write like this: interchange row I with the row j. As I discuss right now, these are some operations, and I can add like this. There are some theoretical part. No need to, just for your understanding, I write it over here. Otherwise, you have to just calculate it. There is no need. So there are some examples are giving how we can pivot and the matrix about the circled element. So these are some more examples for your convenience. I write it. So this is the matrix is given below, and we have to convert this matrix. So first of all, what we have to do? So first of all, this is the pivoting element, and we have to convert it into the 1. So to convert 1, what we have to do? First of all, we have divide it 1 by 3, r1 divided by 1 3. When we divide it 1 by 3, then here we will get the 1. So I observe that here I get the 1, and here I get 5 by 3, and then 9 by 3 is the 3. Now our next aim, we have to draw the 0 over here. So what formula I have to apply to over here 0? So here he apply this formula, r2 minus 2r1. So this is the method to draw. These are the just example. With the help of, for your convenience, I write this example. So these are some rules. Use the Gauss-Jordan elimination method to solve the system of equations. There are similarly, I write some another example for these of system of equations are given. First of all, I write this system of equations in the matrix form. This is the matrix form, and both of them are the same, either write like this or write write like this. So first of all, I have this type of equation. Then our aim is to remove 3 over here and write it 1 in place of 3. So make some operation. So I draw the operation R1. If I add row 1 and row 2, then it will get the 1 and make a row 1. If I make row 1 with the help of row 1, adding row 1 and row 2, then we get 1 over here. Then similarly our next aim is to put 0 over here and to 0 over here. So I apply these operations. So by practicing, when you do practice, then you will understand how we can apply this. Again and again I put over here. So this is now our next aim to become is in this place. I want 1. So we apply the operation like this. We apply some operation and we get in the next slide. We see that we get the value 1 on that place. In the next slide, yes, I observe the value, it got 1, and our next time we want 0 in this place. So with some operations we get 0 over here. Now our next aim, it is a pivot column. Now our aim is to put 1 in this place. In place of 31 I want 1. So apply some operation, then we get some value. With the help of this we apply we get 1 over here. Then after furthermore I want to I want to solve. Then we want 0 in this place, or we want 0 in this place. Then apply some operations, then we get 0 other places. Then this is we apply some operation. This is the Gauss elimination method. With the help of this method I can get the solution. So the solution is 1 is equal to x is equal to 3, y is equal to 4, and z is equal to 1. So this is one type of solution. Use Gauss Jordan method. This is another example. Because today's your syllabus is like up to here. I just give some examples, but your syllabus this week's syllabus is up to here. And this is one example: system of linear equation understanding undetermined the system of it. These are some examples, other examples. I just take some other examples how to solve the system of linear equations. Just similarly take 1 and then rest of the part is 0. Then on the next time take 1 and the rest of the part is 0. So these are some examples. So in this infinitely many solutions over here, I observe that there are a completely row is 0. Over here I observe that there are completely the row and 3 reads 0 is equal to 0, which is true, but of no use to this. They're completely 0. So we use that infinitely number of solutions. And as in the previous section, I observed that 0 is equal to 0. When I try to solve the system of linear equations in the first part, as I discussed you, if I try to cancel this equation and we observe that 0 is equal to 0, then we say it is an infinitely many solution. If I get the value 0 is equal to 9, then we have no solution like this. So this is one type of solution in the system of linear equation. We can also solve like this. These are some examples. A system of linear equations with infinitely number of solutions. A system of infinitely number of solutions. This is an example. These are some values. A system of linear equations that has no solution. Yani, this is the third example over there. As I observed in the previous section, as I told you, if we have two equations and we try to solve this equation, on that time what I get the value 0 is equal to 9. So 0 is equal to 9, then I say it is a not solution. Now in this case, in system of linear equation, now we see how we get the solution. So similarly, on the same pattern, I try to solve. I want 1 in this place and rest of the place is 0. So apply the row operations over here again and again, and then again I want 1 in this place and rest of the place are 0. Then at the last what I get the value. This is the point. Again and again I apply the row operations. Again I apply. So lastly what I observe here, the complete row is 0 and the last there is a value. So it is a no solution. This is an example of the no solution. Observe that row 3 reads x0 x plus 0 y 0 z is equal to -1. 0 is equal to -1. We therefore conclude that the system is inconsistent and has no solution. So these are the I just gave you the three examples with different types. One is unique solution and another is the infinitely many solution, and the third example is there is no solution. System of no solution. If there is a row in the augmented matrix containing all 0 to the left of the vertical line and non-zero entry to the right of the line, then the system of equations has no solution. So with the help of these three results, I conclude that if the system of if the number of equations is greater than or equal to the number of variables in a linear system of equations, then one of the following is true: the system has no solution, or the system has exactly one solution, or the system has infinitely many solutions. If there are fewer equations than the variable in a linear system, then the system earlier has no solution, or it has infinitely many solutions. So these are some results. Now these are some practice questions. These are the next part. So these are the end. This is the end of your lecture. So do you have any question? Okay. Now it is something. I hope there is something. Whatever your doubts are clear little bit, because of in face-to-face class we have a limited time and we have a little limited questions. Now I give you in detail. There are 3 questions I discuss in every type. So I think you understand clearly. Okay, no problem. I will give you the slides, but you have to come before 1 hour in my lecture, in my chamber. So I will give you these slides. So these slides are approximately same as when you see your book. Approximately the books and these slides are most of them are same. Okay. Okay, bye. Take care and Allah Hafiz.